Welcome to Tech Nation, where we explore the latest and greatest in cutting-edge technology. Today, we're going to dive into the fascinating world of ferrofluids. Have you ever seen a liquid that can be controlled with magnets? This is exactly what ferrofluids can do. These liquids, made by suspending tiny magnetizable particles in a liquid carrier, have the ability to change shape, move and even climb up surfaces in response to magnetic fields. Ferrofluids have a wide range of potential applications, from medical imaging to drug delivery, energy harvesting and even cooling systems. They could revolutionize the way we think about liquid dynamics and fluid control. Imagine a world where liquids can be controlled like solids and can perform tasks that were once thought impossible. But that's not all. Ferrofluids can also be used in robotics and could lead to the development of soft, flexible robots that can change shape and move in response to magnetic fields. The possibilities are endless and we're just scratching the surface of what ferrofluids can do. So, if you're ready to discover the amazing world of ferrofluids, and see how this technology is pushing the boundaries of what we thought was possible, then stay tuned, because this is going to be one exciting ride. Trust me, you don't want to miss it. How ferrofluids are made. Synthesis of the magnetizable particles. The first step in making a ferrofluid is to create the magnetizable particles that will be suspended in the liquid carrier. These particles can be made from a variety of materials, such as iron, cobalt, nickel, or other metals. The particles are typically synthesized using a chemical process, such as a precipitation or chemical reduction process. Surface modification of the particles. Once the magnetizable particles have been synthesized, they are often surface modified to prevent them from clumping together. This can be done by coating the particles with a surfactant, which helps to keep the particles suspended in the liquid carrier. Dispersion of the particles in the liquid carrier. Next, the magnetizable particles are dispersed in a liquid carrier. The liquid carrier can be any liquid that is compatible with the magnetizable particles, such as water, oil, or a mixture of liquids. The particles are typically dispersed using a mechanical process, such as high-speed stirring or ultrasonication. Stabilization of the ferrofluid. After the magnetizable particles have been dispersed in the liquid carrier, the ferrofluid is stabilized to prevent the particles from settling out of the liquid. This can be done by adding a stabilizing agent, such as a surfactant or polymer, to the ferrofluid. Filtration and purification. Finally, the ferrofluid is filtered and purified to remove any impurities that may have been introduced during the synthesis or dispersion process. It is worth noting that the process of making a ferrofluid can vary depending on the desired properties of the final product, as well as the materials used to make the magnetizable particles. Let's now talk about some of the applications of ferrofluids. In speakers, ferrofluids are commonly used in speakers to improve sound quality. The ferrofluid acts as a seal between the moving parts of the speaker, helping to keep dust and other particles out. The ferrofluid also helps to cool the speaker's voice coil, which can extend the life of the speaker. In motors, ferrofluids are used to create a seal around the moving parts of motors, helping to keep the motor running smoothly and efficiently. The ferrofluid also helps to dissipate heat, which can extend the life of the motor. In lab-on-a-chip systems, ferrofluids are being used in lab-on-a-chip systems to control fluid flow. Ferrofluids can be used to create a barrier that can control the flow of fluid in a microfluidic channel. They can also be used to create a valve that can open and close to control the flow of fluid. In cooling systems, ferrofluids can be used as a coolant in electronic devices. The ferrofluid can be circulated through the device to dissipate heat, helping to keep the device running cool. In biomedical applications, ferrofluids are being researched for use in biomedical applications, such as drug delivery and magnetic resonance imaging, MRI. Ferrofluids can be used to transport drugs to specific areas of the body, and they can also be used to create contrast agents for use in MRI. In space technology, ferrofluids are being researched for use in space technology, such as in satellite propulsion systems. Ferrofluids can be used to create a magnetic field that can be used to propel a satellite. In art and design, ferrofluids have been used in art and design to create visual effects. They are used to create sculptures, kinetic art and interactive exhibits. In other fields, ferrofluids are also being researched for use in other fields, such as in aircraft engines and in nanotechnology. Some facts and trivias about ferrofluids. We hope you're enjoying our exploration of the fascinating world of ferrofluids. Now, let's share some interesting facts that you may not have known before. Are you ready? Ferrofluids were first discovered by a NASA researcher in the 1960s, while he was trying to find a liquid that could be used as a rocket fuel. Ferrofluids can be used to create a seal in hard disk drives and other mechanical devices. Ferrofluids can be used to create a barrier between two liquids that don't mix, such as oil and water. Ferrofluids can be used in the creation of art, as they can be manipulated with magnets to create unique shapes and patterns. Ferrofluids can be used to create a speaker that can produce sound without the need for a traditional speaker cone. Now, let's continue our exploration into the exciting world of ferrofluids and see how they can change the way we think about liquids and fluid control. Can ferrofluids be the future of space propulsion? The basic idea behind using ferrofluids for space propulsion is that a magnetic field can be used to create a force on the ferrofluid, which in turn can be used to propel a spacecraft. One proposed method for using ferrofluids in space propulsion is called the magnetohydrodynamic (MHD) propulsion system. In an MHD propulsion system, a ferrofluid is circulated through a magnetic field, which generates a force on the fluid that can be used to propel the spacecraft. However, there are still several challenges that need to be overcome before ferrofluids can be used in space propulsion systems. One of the main challenges is that ferrofluids tend to be highly viscous, which can make it difficult to circulate them through a magnetic field. Additionally, ferrofluids tend to be highly sensitive to temperature changes, which can make it difficult to control their properties in the harsh environment of space. Well, that's it for today's exploration of the fascinating world of ferrofluids. We've learned about the properties and characteristics of these unique liquids, as well as some of the potential applications and uses for ferrofluids in various fields, including medicine, technology, and even art. We've also seen how ferrofluids can be used in space propulsion, cooling of high-performance electronic devices, and even creating seals in mechanical devices. We also explored the potential use of ferrofluids in creating soft and flexible robots. But this is just the tip of the iceberg when it comes to the possibilities of ferrofluids. As research and development in this field continues, we may see even more groundbreaking discoveries and applications for these unique liquids. We hope you've enjoyed this video and learned something new about ferrofluids. We'll be back with more exciting content soon, so make sure to subscribe to our channel and hit the notification bell to stay updated. And as always, thank you for watching Tech Nation.